Hi guys, welcome to my chemistry class. Now we're going to start with gases laws. Now the first law we're going to learn about is Boyle's law. This is the main equation for Boyle's law. I'm going to put it here. Okay. Now from the first equation, the main equation, we have initial pressure times initial volume equals final pressure times final volume. Now if you need to isolate for any of the variables in the equation, this is how you do it. Pressure 1, volume is multiplying pressure 1, so it comes to the other side to divide. In volume 1, pressure is multiplying, so it goes to the other side to divide. For pressure 2, volume 2, it's multiplying, so it goes to the other side to divide. And for volume 2, pressure is multiplying, so it goes to divide to the other side. Now, let's read the problem and let's see how can we solve it. A sample of oxygen gas has a volume of 150 milliliters when its pressure is 0.947 atmospheres. What will the volume of the gas be at a pressure of 0.987 atmosphere if the temperature remains constant? Now, one of the main definitions of Boyle's law, this is one of the conditions. Pressure should remain constant. Now, let's highlight the givens and let's try to identify what's the initial and what is the final condition. First, the sample gas has a volume of 150 milliliters and an initial pressure of 0.947 atmosphere. What will the volume be? So we're talking about a final condition of volume, so I need to find volume, but not any volume, final volume. And the pressure, the final pressure is 0.987 atmospheres. So we write the givens and we say initial volume 150 milliliters when the pressure is 0.947 atmospheres. They're asking me to find volume. Final condition of it is unknown, but they're giving me the final pressure of 0.987 atmospheres. Now, final volume is unknown. Now, let's take a look. In this type of problem, unless I specify that you need to give me volume or pressure in specific units, the only thing that you need to take a look or be careful about is that the units related are the same. Example here, pressure 1 and pressure 2, both are in atmospheres, so we can deal with it. Okay, we don't really need to do any conversion. But in the case of having pressure in atmosphere and the other pressure in, millimeters of mercury, for example, then yes, we need to choose one of the units. Now, if I need to find volume 2, I will use the last equation right here. So, first step is to write the equation volume 2 equals pressure 1 volume 1 divided by pressure 2. We have everything we need, so we just plug the values in. Initial pressure is 0.947 atmosphere. Initial volume 150 milliliters. The final pressure is 0.987 atmosphere. Now, atmospheres and atmosphere will be cancelled. That's what I told you. This is the condition that should be accomplished. Units should be the same. It doesn't matter if it's not pascals or if the volume is not in cubic meters, for example. In this case, for gases, it won't matter. Now, let's do this in the calculator, and we have 0.947 times 150 divided by 0.987 and we have a final volume to be 143.92 milliliters. So for Boyle's law, when you have an increase in pressure, you have a decrease in volume. Let's do another problem for Boyle's law. A chemist collects 59 milliliters of sulfur dioxide gas on a day when the atmospheric pressure is 0.989 atmosphere. On the next day, the pressure has changed to 0.967 atmospheres. What will the volume of the sulfur dioxide gas be on the second day? So, what am I looking for? I'm looking for, well, first we write the givens. And the question says, what will the volume be? So I need to find my final volume. Now, what is the exercise given me? It's given me initial volume 59 milliliters. It's given me atmospheric pressure initial 0.989 atmospheres. Next day, that means after, so pressure 2 is 0.967 atmosphere. What will the volume be? Same equation than the exercise before. Volume 2 equals pressure 1, volume 1 divided by pressure 2. We have everything we need. Just check that the two pressures are in the same units. Yes, so we continue. 0.989 atmosphere times 59 milliliters divided by 0.967 atmospheres. Atmospheres and atmospheres will be cancelled, and this will be 0.989 times 59 divided by 0.967. The final volume will be 60.34 milliliters. Conclusion here. When you have a decrease in pressure, you have an increase in volume. Now let's talk a little bit about Charles' law. Charles' law states that, let me place it here, volume divided by time initial equals volume divided by time final. So if you isolate for each of the variables that are involved in this formula, these are how they are isolated. Okay, so we have initial volume, okay, so initial volume, temperature is dividing, goes to the other side to multiply. Final volume, temperature is dividing and goes to the other side to multiply. For temperature 1 and temperature 2, what I did is I switched the formula, the main formula, I switch it. Okay, and from here I can isolate easily. Temperature 1, volume is dividing, goes to the other side to multiply, and for temperature 2, volume 2 is dividing, goes to the other side to multiply, just like we have here. Now, let's take a look. A sample of neon gas occupies a volume of 752 milliliters at 25 Celsius. What volume will the gas occupy at 50 Celsius degrees if the pressure remains constant? Now, I forgot to say, but here for Charles' law, temperature should be always in Kelvin. So I'm going to write here, temperature is measured in Kelvin. Now, how do we convert to kelvins? kelvins. If you have Celsius, Kelvin is equal to Celsius plus 273. That is the formula. Now let's take a look. Let's write the givens from this problem. It says initially this gas occupies a volume of 752 milliliters. So this will be my initial condition for volume. And it says an initial condition also for temperature. So we need to find temperature 1 equals 25 Celsius degrees. So we need to convert to Kelvin. How? By using the formula. Celsius plus 273 equals 25 plus 273 298 Kelvin. Now take a look. The temperature here for Kelvin, you don't need to specify that these are degrees because Kelvin is the absolute scale for temperature. Now let's continue. What will the volume of the gas occupy at 50 Celsius? So the final temperature is 50 degrees Celsius. So we convert to Kelvin, sorry about it. Celsius plus 273, 50 plus 273. So Kelvin, the temperature in Kelvin is 50 plus 273, 323 Kelvin. So this will be my final temperature, and I need to find what volume will the gas occupy. What volume will. So I need to calculate the final volume. For the final volume, I have the second equation right here that says volume 2 equals volume 1 divided by temperature 1 times temperature 2. Initial volume, just plug in the givens, 752 milliliters divided by 298 Kelvin times 323 Kelvin. So this will be 752 divided by 298 times 323. So the volume 2 will be 78.04 milliliters. Now something is wrong. Let me see. Here in my calculator. So as I noticed that my answer didn't make sense, because this is not just about writing a random number, you know. This is about evaluating if what you did was right. So I noticed that my answer didn't make sense. So let's see. It's that I missed a key in that calculator. I did it now already. 823.38 milliliters. What means that an increase in temperature makes an increase in volume. So if the temperature rises, the volume rises. In conclusion, that's what you can write about it. Now for the last problem, we have a balloon full of air has a volume of 2.75 liters at a temperature of 18 Celsius. 18 degrees Celsius. What is the balloon's volume at 45 degrees Celsius? So as I told you before, every temperature here in gas laws should be in Kelvin, and we convert Celsius to Kelvin by adding 273. So let's write the givens and let's identify what is requested. What is the balloon's volume at 45? So that means that I had an initial volume of 2.75 liters. I had an initial temperature of 18 degrees Celsius. I convert to Kelvin and I say that 18 plus 273, this is 291 Kelvin. My temperature 2 is 45 Celsius degrees, which means 45 Celsius plus 273. 45 plus 273, the conversion is 318 Kelvin. Now, what am I looking? I'm looking for volume at that temperature, so that means volume 2 is unknown. The equation for volume 2 is right there. Volume 2 equals volume 1 divided by temperature 1 times temperature 2. Volume 1, 2.75 liters divided by 291 Kelvin times 318 Kelvin. So, the analysis before the answer is, I had an increase in temperature, so in conclusion I should have an increase in volume. An increase in temperature represents an increase in volume. Let's see if that happens. 2.75 divided by 291 times 318. Volume 2 is 3.01 liters. So yes, the volume increased because the temperature increased, so we did right. Okay guys, this is it for today. Enjoy and see ya.